Hello everyone, welcome to the second lesson of DePHY. Let me introduce myself first. I am Shooter, a Solana developer. At DePHY, I am responsible for developer relations and I am also an open source enthusiast. First, let me introduce DePHY. DePHY is an integrated DePIN framework that significantly reduces the cost and time associated with developing DePIN projects. DePHY provides open source hardware solutions, a decentralized messaging layer, and a token economic model for all DePIN projects. The messaging layer of DePHY uses trusted execution environments, TEE, and zero-knowledge, ZK, proofs to ensure data verifiability and reduce latency. This is our official website, where you can find more information. Next, I will introduce DID, which stands for Decentralized Identity. DID is a decentralized digital identifier that allows individuals, organizations, and even IoT devices to create and manage their unique, self-sovereign identities. Unlike traditional usernames, email addresses, or social security numbers, DID is not controlled by centralized institutions and helps avoid single points of failure. DID is generated, owned, and managed by the identity holder, enabling secure and private interactions with other applications in the digital world. Leveraging blockchain technology, DID creates a decentralized, tamper-proof, and highly secure identity management infrastructure. Only the identity holder can verify and update their DID without intermediaries. Compared to centralized identity management systems, this approach offers better security and privacy. Now, let me describe a core process of DePHY. An innovative aspect of DePHY is its unique asset securitization method. By assigning a unique DID to each physical device, DePHY converts tangible assets into financial products that can be traded on the blockchain. This process is not just digital but involves a complex financial procedure. DePHY's DID system acts as a bridge between physical DePIN hardware and blockchain-based digital identities. Devices, such as GPS stations or smart devices, can be registered and activated through this process. Each device is assigned a DID, and the registration process is completed by the device provider, while activation is performed by the device user. Assigning a DID to each device is crucial for asset securitization and further financial derivatives based on DePIN. Based on the DID, the system generates NFTs representing device ownership and revenue rights. These NFTs can be freely traded on secondary markets and automatically manage revenue distribution through smart contracts, greatly enhancing asset liquidity and management efficiency. A key feature of DePHY's asset securitization process is over-collateralization, meaning the value is supported not only by the current hardware value but also by the anticipated future token earnings of the device. This over-collateralization provides additional security and stability for financial products built on these assets. To ensure accuracy and reliability, DePHY also integrates a robust Oracle system that continuously feeds real-time information about hardware performance, market conditions, and agent generation rates back to the blockchain. This real-time data flow allows for more dynamic valuation of NFTs, ensuring their value accurately reflects the current state and future potential of the underlying hardware. Now, let me introduce DePHY's ecosystem projects. The first one is StarPower. StarPower is an innovative platform focused on enhancing the capabilities of virtual power plants through blockchain integration. In energy-focused DePIN solutions, ensuring accurate data transmission and processing is crucial. StarPower's main challenge is achieving trustworthy data transmission, processing, and accurate execution of economic models. By utilizing DePHY's middleware, StarPower can achieve seamless data transmission between blockchain and DePIN devices and improve the execution efficiency of economic models through reliable and secure data relays. Additionally, StarPower simplifies hardware design and manufacturing processes through DePHY's open-source hardware designs, facilitating rapid prototyping and global hardware distribution. StarPower ensures the verifiability and security of all network messages using the DePHY DID system. Devices in the network are equipped with TEE modules to process and sign data securely, ensuring data integrity. The second ecosystem project is APIS. APIS Network is building a decentralized, trustless GPU network. This involves using multiple independent GPU resources in a distributed network to perform computational tasks without relying on a single data center or service provider. In APIS's business scenario, users request computation tasks via AI agents, and these tasks are executed using distributed GPUs and returned to the users via proxies. This scenario faces several challenges. First, there is the need for verifiable and trustworthy transmission channels. Users need a channel to validate and trust AI requests, ensuring data integrity during transmission. Second, there is the need for result verification mechanisms. As AI task results cannot be directly verified mathematically, reliable verification mechanisms must be established, involving blockchain technology and distributed verification solutions. Third, ensuring the security of distributed GPUs is crucial, including preventing malicious nodes and ensuring that all participating nodes complete a series of guarantees and establish reward and penalty economic models. Fourth, the security of economic models is vital for the stable operation of enterprises. For decentralized GPUs, DID addresses the universal and unique identification issues of devices on the network and provides unique, verifiable DID for economic model executors and GPU devices. Additionally, DePHY's res-taking mechanism ensures the security of APIS's economic models. Lastly, let me introduce DePHY's developer tools. Here is DePHY's GitHub account, which currently features two projects, DePHY ID for Solana and DePHY ID for EVM. The Solana project is in its initial development stage, and we welcome everyone to fork it. DePHY for Solana includes several modules. First, the program, which is the main code of the project and handles registration, activation, etc. Next is Indexer and Explorer. Indexer is the Solana state indexer, while Explorer displays the relevant states, such as device status, ownership, activation status, and collateral status. JavaScript/Rust client are SDKs for DePHY in two languages, generated using Solana's Kenobi. You can use these SDKs in JS and Rust to call DePHY SDK's basic functions. DePHY Wallet is used to generate wallet addresses for managing devices. Product Program Template is a template for deploying your program to manage DePHY devices or directly mint devices with customizable minting logic. There are also two examples. Simple Data Subscription with Quill, which saves data to Quill for other services to subscribe to, and Device Simulator, which simulates devices for testing registration and activation. For DePHY ID for EVM, the contracts folder contains the main contract code. E2E is the testing code and provides a good example. The test folder contains testing code for Foundry. The script folder includes deployment scripts, while extensions provides proxy addresses for product owners. The templates folder contains contract templates for device providers to customize their business logic. There is also a tools folder with a tool set for simulating devices, SDKs, and a React UI demo. For resources, I have provided two links to the GitHub repositories for DePHY for Solana and DePHY for EVM. Feel free to check them out. That concludes this video. Thank you for watching.